This is Analysis and Redesign of Can Openers by Charles Newton, Liam Clayman, Adam Good, Connor Strang, and Matthew Rosolowski. Can openers remove the lid of the can. A circular blade is inserted into the top of the can and then moved around the top edge by a cranking handle that rotates a gear that rotates the can. It's designed to be able to fit on a variety of different sizes of cans, and the estimated production volume for primary and secondary consumers is around 750,000 units per year. The primary and secondary customers for can openers are households and commercial use, respectively. For households, can openers need to be able to open a wide variety of cans, need to be easy to use, safe and reliable, and their total volume is about 417,000 can openers per year. On the commercial side, restaurants, catering, etc., and food production use can openers. They need to be fast and durable as they're used many times a day quickly. They also need to be safe and reliable, and about 333,000 can openers are bought in the industry per year. Shown here is the fast chart for a can opener. Starting on the left, you see open containers, as you move to the right to open bottles or open cans, you see the how each thing is performed. Then we also have a few branches with assure dependability, assure convenience, enhanced products, and please senses that show how can openers are safe and how we're hoping to improve upon them.
Here is an exploded view of the can opener we will be using. It shows all the parts, including the handles, gears, plates, and twisting handle configuration. Here are two ways to assemble the can opener. The left sequence involves assembling the opener one part at a time, starting with the right plate, going all the way down to the handles. And the right side is very similar, but assembles both the left and right halves in parallel before connecting them together in the final step to make the finished product. When comparing the two sequences, it's found they are very similar in the first four criteria, with the first sequence having the upper hand in ease of locating parts, and the second sequence having the upper hand in ease of fastening. The second sequence then outscores the first in the ease of assembling by parallel category because it is almost entirely in parallel, while sequence 1 cannot be done in this fashion.
By taking the 9 functions from the FAST diagram and all of the parts from the can opener assembly, we were able to create the function component mapping matrix. We marked which parts were responsible for which functions, and we found that the rotating of the can opener around the can to be the most complex operation.
This is the bill of materials and rough estimation of the total cost per can opener. For each part, we were able to break down the cost using methods and materials that were given in lecture, as well as some assumptions that had to be made. And then using these broken down costs, we were able to find the total unit cost per part and the total overall cost per can opener. This ended up being $22.73, which is relatively high and something that we can hopefully bring down.
After creating a bill of materials, we can then move to creating a quad chart, which plots the functional importance of a part over the mechanical and assembly cost of it. This allows us to see which parts need to be eliminated, redesigned, and left the same. From this, we can see that the right plate, the left plate, the twisting handle insert, and the blade spinning insert are both very functionally important, but also have a high manufacturing and assembly cost, so they need to be redesigned. You can also see that the rivet, plane washer, and the head cross recess screw are both low manufacturing cost and low functional importance, so those can both be eliminated.
We took each of the 9 functions from the FAST diagram and compared them between our 2 consumer groups. We found that the biggest difference between them was the speed needed. For household use, being slower is not as much of an issue due to the low volume of cans needing to be opened. Whereas in a commercial use, more cans are needed to be opened, so the speed and durability are much more important, even at the expense of comfort. In order to design for the higher speed of the commercial use of the can opener, we created different modules for the twisting mechanisms between the household and commercial uses. The parts that are not in the rotating mechanism are common between our two designs.
Here we have the CAD for the product family design. We have our original design, which is used in households, where we see the original twisting handle and the original gear combination. And then over on the right, we can see that the handle material has been changed to increase durability for use in restaurants and canneries, etc., for large-scale use. And also the gear ratio has been changed to increase speed. And then in the bottom left, we can see what components both these CAD models have in common. In the product family design modified assembly, we have changed our original assembly in order to postpone product differentiation. And here we can see that the products remain the same during assembly until the twisting handle, where they split into two groups, the ones used in household and the ones used in commercial use. This concludes our analysis and redesign of can openers, and we will now open the floor to questions.